Welcome to qnawire.
Consider the function f of x equal to the sine of x plus the cosine of x. We want to find the intervals of f for which it is increasing or decreasing. So this we can, diagnose via the derivative. So if f prime of x is positive, then this implies that f of x is increasing, and if f prime of x is negative, then this implies that f of x is decreasing. So let's take our functional form for f of x and calculate its first derivative. F prime of x will then give us the cos of x minus the sine of x, because the derivative of a sine is a cos and the derivative of a cos is minus a sine. So now let's check when f prime of x is positive and negative. And maybe the easiest way to see this is to draw a graph. For me, the easiest way to see this is to check when f prime of x is equal to 0. Anyways, we need to find the critical point in question B. So f prime of x is equal to 0 when the cos of x is equal to the sine of x. And for x ranging between 0 and 2 pi, this occurs at 4 locations. X equal to pi over 4. Excuse me, they only intersect at 2 locations. X equal to pi over 4 and 5 pi over 4. For x ranging between 0 and pi over 4, the cosine is going to be larger than the sine. Okay, here a graph will be extremely useful. I will draw the cosine or the sine in red. So the sine starts at the 0, at the origin, intersects the x-axis at pi and 2 pi. Yet the cosine starts at +1, has a minimum at pi, and a maximum at 2 pi. So this here was our first point of intersection, pi over 4. And this here is our second point of intersection, 5 pi over 4. And we see that the cosine is larger than the sine function for x ranging between 0 and pi over 4, and pi over 4, 5 pi over 4 to 2 pi. And we're just going to unify these two regions. On the other hand, the sine is less than the cosine for x ranging between pi over 4 and 5 pi over 4. So in this first region, f of x is increasing, in the second region, f of x is decreasing. Next, in question B, we want to find the local max and the local minimum values of f. So we've already found our critical points. Our critical points correspond to x equal to pi over 4 and 5 pi over 4. Now to diagnose whether this critical point is a min or a max, we need to look at the second derivative. Let's calculate our second derivative. F prime of x will give us minus the sine of x minus the cos of x. Now let's evaluate f prime prime of pi over 4. This is going to be, well, we don't need the actual value. I want to know it's going to be a negative quantity, because sine of pi over 4 is 1 over square root of 2, and the same with cos of x. So negative negative is negative, which means that this point corresponds to a local max. On the other hand, f prime prime of 5 pi over 4 is positive. Both the cosine and sine are equal at this point, and its negative value is minus the square root of 2 over 2. And with these extra minus signs, we find f prime prime of x is positive at this point, meaning that this critical point corresponds to a local min. And if we want to find the actual values, well, of local max, local min, we simply need to evaluate f at the critical points. So f at 5 pi over 4 returns the square root of 2, and f of 5 pi over 4 returns minus the square root of 2. I'm just going to box all the answers. Next question, we want to find the intervals of concavity and inflection points. So the main concavity, it's similar to whether f is increasing or decreasing, but this time has to do with the shape of the curve. For instance, if f prime prime of x is positive, then this implies that f of x has a positive concavity. Positive concavity looks like this. Excuse, that's negative. Positive concavity looks like a smiley face. But if our second derivative is negative, then our function f has a negative concavity. And the inflection points, similarly to before, correspond to critical points. So let's go back to our second derivative. F prime prime of x we know is equal to minus the sine of x minus the cosine of x. And we find the inflection points by equating this to 0. So in other words, we want to know when is the cosine of x equals to minus the sine of x. And this corresponds to x equal to pi over 4 and 7 pi over 4. So we have two inflection points, and we're going to use this similarly as before to determine our interval of concavity. So now we want to know when is our second derivative positive or negative. To help us solve our problem, I think it's easier to draw a graph like before. But in this time, we drew a graph of cos of x and sine of x. Now we're going to invert one of them. So let's invert the cos of x, the sine of x, excuse me. I'll draw it in red. So this here is minus the sine of x. And in blue is the cos of x. So now we see that we're going to have a positive concavity when this blue curve is greater than this red curve here, and this first intersection point occurs at 3 pi over 4, excuse me, and the second one at 7 pi over 4. So we will have a positive concavity in this region and this region. So for x ranging between 0 to 3 pi over 4, and for x ranging between 7 pi over 4 to 2 pi. And otherwise, we will have a negative concavity, and this will be for x ranging between 3 pi over 4 and 7 pi over 4.